Right, well, welcome to the Halifax and District Amateur Radio Society, and this is the inaugural talk for the 2025 Buildathon for the Kanga Little Roo 40-meter SSB or CW receiver in this little box here. So what I'll do, I'll step you through what this receiver actually is, because it's quite a clever little circuit. Built up, designed on one of the sudden receiver designs from the GQRP Club with a few modifications on it. So I'll step you through what those modifications are. Look at the build sequence, and there's one or two little hints and kinks on it, which you've got to watch out for. Some of the silk screening on the board is a little confusing. So let's kick off by looking at what a direct conversion receiver actually is. Obviously you need an antenna, one antenna there, and then we're going to have a bandpass filter. Now a direct conversion receiver literally takes the RF, mixes it with a local oscillator at the frequency of the carrier of the RF, or where the carrier would be if it was an SSB signal, and then it directly converts that mixed product into audio. One of the problems with this is that the front end can be a little bit wide open. So they have put a bandpass filter in there. More of that in a moment. Then we come on to the mixer itself, and this is the lovely NE612. It's a double balanced mixer with an oscillator on board, which you can just attach a couple of components to, and it will oscillate quite happily and mix away for you. It's a very handy little circuit. Getting quite hard to get hold of now in through-hole design. You get them now as tiny little surface mount devices. And one of the things we have to watch for in this kit is that the mixer is a tiny little surface mount chip on a printed circuit board, which we have to solder pins onto to plug into the... sorry? Has it got the pins on that one? Yeah. Oh, now listen, because on the one I got, it was the pins were actually loose and you had to push them in and solder them on. Oh, great. If they've done it, that's even better. So we then have to control the frequency. You can do it with a standard tank circuit with a capacitor and inductor, or you can do it with a varactor, which is a variable capacity diode. Reverse bias the diode, depletion layer widens out, closes down, you end up with a capacitor. So what this is doing is supplying a small amount of DC to a variable capacity diode, a varactor, which is then in parallel with a fixed inductor. And that's what's giving you the oscillator frequency. Really clever little idea. So that's one of the pots on the control. So it's not a vane tuning capacitor, it's actually a pot just regulating some DC. Next we have the LM386, the good old audio chip, loved and known by everybody. And because it's a balanced mixer, they use both the non-inverting and inverting inputs of the amplifier. That's why I've drawn two lines. You'll see that when you come to the circuit diagram. And straight out to a speaker. It's simplicity itself. As I said, one of the problems with a direct conversion receiver is they can be as wide as a barn door. The Kanga Rooster, which is the CW transceiver, receives BBC TalkSport beautifully where I am, and that's about it. Because 200 kilowatts is just on top of that hill up there, and it's not very good. So I did the bandpass filter for that one, but I think this one should be okay. So that's the basics of the receiver. So what's the mixer oscillator actually doing? Well, it's going to receive the lower sideband on 40 meters. And the lower sideband contains individual tiny little carriers, each one representing one of the audio frequencies in your modulation, from about 300 hertz to 3 kilohertz. That's what's a sideband. No carrier, just the sideband with full power. So if we have a look at that, where the carrier ought to be and where the transceiver removes it with its sideband filters and its balanced mixer, that's where your transceiver is tuned to. And if I put in there a tone of, say, 3 kilohertz, just a single tone, we'll see what happens. So we have a 3 kilohertz offset from where the carrier ought to be. If we now insert the local oscillator where the carrier ought to be and put it back in again, carrier insertion or reinsertion, then we have something to work with. And what the mixer will then do, it will look at the difference in the carrier frequency, which is a local oscillator, and that particular frequency in the lower sideband. And what you get is a mixed product which is 3 kilohertz plus the local oscillator, which we don't want, and 3 kilohertz minus the local oscillator, which we do want, which is in fact audio. And there it is. It's as simple as that. So by reinserting the carrier into a double balance mixer, that's demodulating an SSB signal, this should sound familiar to you. And what it is, in fact, is a product detector. That's exactly what's happening in an SSB receiver. So your little balance mixer with its little varactor diode oscillating happily away is acting as a product detector. Perfect. Works for CW, works for SSB, and AM if you're tuned up on the heterodyne as you tune around. So let's have a look at the circuit diagram. This is the original GQRP design. And if we have a look, this is the filter, the front end filter. It looks a little bit like an IF stage. And that's basically what it is. There are a couple of what appear to be IF transformers with tank circuits built around them and a coupling capacitor, and then we're straight into the RF input of the mixer. What Kanga have done is to remove that and put in there a ceramic resonator. Ceramic resonator is like a crystal, not quite as tight as a crystal, which we don't want a very tight crystal, we want something a little bit wider than that. So it behaves a little bit like a crystal, slightly wider bandwidth. And what this does, it gives us a lovely notch in the front end as a bandpass filter. And it's actually better, slightly better than the rooster transceiver. Down here we have the circuit for the oscillator. There's the coil, there's the variable capacitor, which you can use as a standard tank circuit. There's a coupling coil there which goes off to the frequency counter in the GQRP club kit. And here is the varactor. So there we are. That's all it is. There's the pot. That's giving it some DC bias to change its capacitance. That's the fixed inductor, which looks like a tiny little resistor in your kit. And then that's straight into the local oscillator input. Dead easy. On this one, because it's quite narrow banded, there are 2 varactors supplied with the kit. So we have to watch when we're building this kit, whether you're building for CW or SSB. There are 2 varactors. One is a tiny one. That's the CW one. The bigger one is for SSB. And there's a couple of other components. I think there's an inductor used to change and a couple of capacitors as well. So it's tiny. If you're not used to soldering, I know some of you have been practicing, it is quite tiny. And some of the holes are plated through, which means what they do, they put a tin plate through from one side of the PCB to the other, which links the tracks. That's really good. It helps to give you good connectivity between the tracks. What it also can do is solder tends to track up the tin plating inside the hole, and as you try to, if you get the component in wrong and you try and desolder it, you've got to suck all the solder out from inside the hole as well. So do be careful when you're trying to solder it together. We can get them out, but it's not 100% guaranteed. So there we are. That's it. Really simple. It's a beautiful little job. It really is. It's a smashing little kit. Kanga put some fantastic little kits together. Love a little receiver. Okay. That's the finished product. We have, at the top of the board, there is the DC regulator. That's a 5-volt regulator. And then we have this section here, which is the audio amp. That's the LM386 and the various bits and bobs to go with it. We then have the ceramic resonator and the varicap tuning. So that's a ceramic resonator, that little blue thing there. The varicap diode is sitting just there. And that is one of the inductors that tunes against it there. This is the, that's the balance mixer underneath the big number 4. This on my kit, and Martin mentioned I had actually put the pins on. On my kit, these row of pins here, you had to push them into the socket for the IC and then solder them onto the board, which was a bit of a pain, but it's okay because they waggle around all over the place. That's all it is. These 2 pots here are just the upper and lower frequency of the receiver. That is your audio gain, which is straight off the antenna coming in here, and this is the DC bias for the varactor. What you get in the box is the circuit board, a tin, a little bit of insulation, which I suggest you make slightly better because I was a bit looking at it and thinking, don't like that. And you get 4 bags, or 5 in actual fact. You get each stage clearly labelled as per the instructions. And they do very, very good instructions. So read through each stage, one section at a time. Open one bag at a time. You may be asked to open things from the semiconductor bag and start building the oscillator and putting the amplifier, and I suggest you don't until the very end, until we've made absolutely sure everything's going all right. You know, so we have a chance with passive components to see what you're doing, and then we can put the IC in. Put the IC socket in, but some you'll find that some of these capacitors are a bit close to the socket. So it's better to populate the board with the tiny little components, pop the socket in last, and then, once you've checked the voltage regulator out, there is a test for that. Make sure it's not backwards or anything stupid. And we can put the IC in, and then we should be cooking with gas or electric. So build it one stage at a time, identify which components are for CW, which ones are for SSB. It's quite clearly labelled in the instructions. When you start to build this thing, the first instinct is to rush ahead a little bit, start throwing things at it. Some of these components are really tiny, and the markings on them are minuscule. So I have got some magnifying glasses, which you'll need. I certainly need them. I can't see for death at the moment. It's terrible. So these tiny little capacitors, it might have 210N or something on it, and it's like that big. So do be careful with these things. They're not for the short-sighted. So do identify them. How do you do that? Sorry, I'll just run through the parts list. Pack of semiconductors and 4 packs. That's what I do. I lay it out on a piece of paper. If you can find some conductive foam, you can buy it on Amazon, black conductive foam. You can actually stick the bits in the conductive foam. Don't use any other kind of foam because some of these things are static sensitive. Lay them out so you know what they are. Make sure you can identify them. I've got some cards with the resistor colour codes on if you need them, but the instructions do tell you what the colours are. So everything should be there for you. Lay everything out and then start to work in the order of the instructions in a logical process, one stage at a time. It's not a race. This thing will go together quite quickly if you let it. The whole point is to enjoy it and get it right. There is one tiny piece on the circuit board which I got wrong, and it's this. That says C13, that says LED. Guess where I put the LED? Yeah. And those plate through holes I mentioned. So yes, do be careful. So the LED is here, and that's C13, so it's a little bit confusing. And it's a tiny little LED as well. Yeah. Yeah. So that's it. So that's the plus side there. That's the flat end there, and that's the capacitor. That's where it goes, guys, ladies and gentlemen. There. That side. Got it? Okay. Then we go on to the audio stage. Now notice we haven't put the chip in yet. We don't do that. We're just going to put in some capacitors, most of the audio side of the capacitors, and the headphone jack there. That's where it goes. Remember that these capacitors are polarized, and the white strip there is negative, which goes against this blob at the end here. So positive, negative. Make sure you're getting the right way around. Strange things will happen. Stage 3 is the oscillator. This is where you've got to make some choices. So lay the parts out, make sure you understand which is which. These two parts here are the two varactors. That's the CW, that's the SSB one. Make sure you know which is which. So it doesn't tune all the way up to the top of the 40 meter band. It tunes nearly all the 40 meter band for SSB, and it's pretty good on CW if you're interested in CW. So that's the varactors that set the oscillator tuning along with a couple of other components. And there are a couple of other parts to choose as well. There we are, written on a piece of paper. You see, logical process, so you know what you're doing. The RF stage is fairly simple. Each stage is clearly described in the instructions, but you'll see there is a BNC connector, this one here. And if you are using a 15 watt iron, you will struggle with it. So we'll have a couple of 70 watt irons out on the table, and it may just be, we'll give it a little scrape around the pins as well, because they do plate these things with something, I have no idea what. It's like nickel, but it's some kind of plate. It doesn't easily take solder until it's red hot. So you just be careful with it. That is the build, ladies and gentlemen. It's really simple, and I hope you enjoy it. So we'll set the tables out next week. If you bring some tools along with you, that's even better. We'll try and get some extension cables out so you can all power your kits up or share them. We have got magnifying glasses. We've got some side cutters, great stuff. Well, pliers, we've got multimeters. I hope On with all the gear you should need, and about 4 or 5 soldering irons as well. But if you have some kit, it will certainly help if you bring it along with you. It will save us a lot of time. So do take a deep breath. Read the instructions before next week. It will really help.
We really appreciate you taking the time to watch this video. Don't forget to check the video description where you'll find additional information about the video you've just watched, along with links to products used and to the HADARS website. If you enjoyed this presentation, please feel free to hit that like button. Maybe you'd also consider subscribing and clicking the notification bell so we can let you know the next time we release another video. Thanks again for watching.